Hello everyone. I'm Juan Carlos Arevalo Perez from Universidad Juárez Autónoma de Tabasco, Mexico. Here, effect of amount of silver as dopant on titanium dioxide by photodeposition for solar removal of sildenafil is present. Therefore, it is important to use treatment capable of removing these contaminants. Heterogeneous photocatalysis has been shown to successfully remove these substances dissolved in water. Unfortunately, um, unfortunately, this process using titanium dioxide, which is only activate under UV light. But this disadvantage has been overcome by doping metallic or non-metallic ions on the surface of the titanium dioxide. This reduces the electron hole recombination and improves the spectral response. It's known that metallic silver nanoparticles as dopant forms surface resonance plasmons, which also help to improve photocatalytic oxidation photocatalytic oxidation by forming an Stokes barrier between the interface of the titanium dioxide and silver nanoparticles that also increase the separation between electron and holes. Therefore, therefore, titanium dioxide doped with silver at different concentration prepared by the modified photodeposition method are proposed here to evaluate the effect that silver has a dopant on the photocatalytic oxidation of sildenafil under sunlight. The catalysts were prepared by photodeposition using a 1:1 water isopropanol solution in which the necessary amount of silver was dissolved in the and then the titanium dioxide powder was dissolved. The system uh, was stirred for 10 minutes and bubbled with nitrogen gas for 10 minutes. Then uh, a submersible UV lamps was introduced for 60 minutes. The said solvents were removed by decantation and the solid was dried in an oven at 120 centigrade degree for 24 hours. The materials were characterized by nitrogen physisorption, XRD, SIMS, and UV-Vis with diffuse reflectance. Photocatalytic evaluation was carried out in solar simulator with a previous absorption equilibrium between the catalyst and the contaminant. Reaction monitoring was performed by UV-Vis spectroscopy, performing stability tests in reaction with 5 reused cycles and using scavenger to identify the main photogenerated species responsible for the sildenafil oxidation. The results uh, show that the silver doping doesn't now significantly affect an specific area, diameter, and pore. Only the anatase crystalline phase was identified in all materials and the crystal size did not show significant change. The samples with the highest silver content exhibit the small signal attributed to cubic silver oxide. Silver doping reduced the bandgap energy of the titanium dioxide and showed evidence of the sulfide resonance plasmon due to the presence of the metallic silver nanoparticles. Irregular particles with a uniform morphology were observed by SIM, and EDA's analysis showed the mapping of the silver, which has a good good distribution. Its content is close to the calculated ones. The optimum amount of silver doping in titanium dioxide was 1%, since this catalyst was the most active and showed the good stability in the consecutive, consecutive reaction. Hydroxyl and superoxide radicals were shown to be the photogenic species that the most influential in the oxidation process of sildenafil under sunlight. Thank you very much. Sorry. As a conclusion, we know that the modification of the photodeposition method was successful. The addition of silver as a dopant improved the photocatalytic properties of the titanium dioxide and enhanced the absorption of light towards the visible region. The sample doped with 1% silver was the most active, showing great stability in its photoreactivity, generating mainly hydroxyl and superoxide radicals to oxide sildenafil under sunlight. Now, thank you very much.